Hey everyone, welcome back to another explainer. I gotta tell you, I am incredibly excited about today's topic because we're going on a bit of a journey. Our mission today is to completely demystify virtual private networks, or as we all know them, VPNs. We're gonna decode the cryptography, unravel the network routing, and look at exactly how your data travels safely across what is, honestly, a wildly unpredictable internet. So, get ready to learn. You know, we do this literally all the time. You open an app on your phone or laptop, you tap that big, friendly Connect button, the icon turns green, and bam, you feel safe. But what's really happening when you connect? Like, what is actually going on behind that simple button click? How does your device suddenly become completely invisible to outside observers?
Okay, let's dive right into this. Here is our roadmap for today's explainer. 1. What is a VPN? 2. Everyday VPN use cases. 3. The VPN handshake. 4. The art of encapsulation. 5. Protocols and top-secret security. And finally, 6. Drawbacks and split tunneling. That's exactly how we'll track a single data packet's journey today.
All right, starting off with Section 1, what is a VPN? The ultimate cybersecurity tool. At its absolute core, a virtual private network is a security technology. It creates an encrypted tunnel between your device and a remote server. The whole goal here is hiding your real IP address and keeping your traffic completely private. So basically, a VPN is just a super secure way of moving your personal information safely from trusted networks across totally untrusted networks, like the public internet. And this brilliantly illustrates the problem. Picture the public internet like you're riding in an open-top hovercar on this totally chaotic digital highway. Everyone's standing on the overpasses. Hackers, your internet service provider, random advertisers, they can look right down into your car and see exactly what you're carrying. Your emails, your passwords, your browsing history, the whole shebang. A VPN basically builds a massive, opaque, energy-shielded armored tunnel right over your lane. Suddenly, no one can see who you are or what data you're transporting. It's a real game changer. Moving right along to Section 2, Everyday VPN Use Cases, why we actually need the armored tunnel. Let's look at the actual practical applications for this tech, because average users and remote workers really do need this every single day. First off, privacy protection. It shields you from your ISP, who, by the way, might otherwise log and sell your browsing data. Second, it gives you security on inherently unsafe public Wi-Fi networks. Think about the local cafe or the airport. It also lets you bypass geo-restrictions and censorship by masking your real location, which unlocks region-limited content. Plus, because your ISP can't see what you're actually doing, they can't selectively throttle your connection while you're gaming or streaming. And finally, for sure, it is absolutely essential for secure remote access to your company's internal corporate resources.
Up next, Section 3, the VPN handshake, preparing the secure connection.
Let's see how this builds, right? This is the crucial preparation phase before any actual data is sent. Step 1. When you click that Connect button, your client sends a connection request to the VPN server. Step 2 is authentication. Basically, they verify each other's identities so your device knows it's talking to a legit server, not some imposter. And Step 3 is the security negotiation. Using protocols like IKE, the two devices sit down and negotiate a contract. They agree on the exact mathematical locks and keys they're going to use to protect your session. And once this handshake is successful, boom, the tunnel is open for business. Which brings us to Section 4, the art of encapsulation, hiding the payload in plain sight. Now, what's really interesting here is this sealed envelope analogy. Every single piece of data your device sends, a website request, a text message, is a data packet. Think of that original data packet as a confidential letter. If you drop it in the mail as is, anyone can read it. Encapsulation takes that letter, encrypts it, and places it inside a brand new sealed outer envelope. This outer encapsulated packet has totally new routing instructions that only point to the VPN server, which completely hides your true destination and the actual payload inside. Let's walk step by step through exactly how that encapsulation process happens. Step 1. Packet capture. Your VPN software intercepts the network layer right on your device before it even leaves. Step 2. Encryption. It scrambles the payload so it is completely unreadable. Step 3. Header addition. It slaps on a new header, that's the outer envelope we just talked about. Step 4, tunneling. That fully encapsulated packet is shot through the encrypted tunnel over the internet to the remote server. And finally, Step 5, decapsulation. The VPN server gets it, removes the outer envelope,
uses the agreed-upon keys to decrypt the inner packet, and then transparently routes your original request to the actual destination website. It's just a beautifully precise system.
Onward to Section 5, Protocols and Top Secret Security, the math behind the magic.
So, the absolute crucial point here is something called AES 256 encryption. This is an advanced, symmetric algorithm, often used in GCM mode, and it provides literally top-secret level cryptographic protection. It makes the data completely opaque. The only way to read what's inside that packet is to possess the exact shared session key that was established during the handshake. Without that key, even the most powerful supercomputers on Earth would take millions of years to guess the combination. No way they're getting it.
Now, these algorithms are carried by different VPN protocols. Think of protocols as the languages the tunnel uses to operate, and you can optimize your own setup based on exactly what you need. For instance, if you're a gamer or a streamer, WireGuard is incredible. It gives you speeds up to 4 times faster because it has a really minimal header structure. If you're a business user handling highly sensitive stuff, OpenVPN is your go-to. It offers enterprise-grade reliability and can actually disguise itself to evade strict firewalls. And if you're a mobile user constantly on your phone, IKV2 is fantastic and allows for seamless switching, meaning you won't drop your secure connection when you walk out your front door and switch from Wi-Fi over to cellular.
Now for Section 6, Drawbacks and Split Tunneling, Balancing Security with Performance. Gotta be objective here, putting envelopes inside of envelopes adds weight. This extra header bloats can cause bandwidth bottlenecks and performance overhead. Sometimes the packets get a bit too big, which requires MTU adjustments, fragments data, and introduces latency. Also, corporate and national firewalls can actively block VPN traffic. And crucially, a VPN only protects data in transit. If you have malware on your actual endpoint device, a VPN can't save you. Finally, it's worth noting that recent academic research has highlighted some vulnerabilities where attackers on the exact same VPN server might manipulate TCP or UDP sessions. This actually violates the non-interference property of the server, so it's a good reminder that cybersecurity is an ongoing cat-and-mouse game.
But hey, there are some pretty clever solutions to these drawbacks. Enter VPN split tunneling. This feature literally lets you split your traffic. You can route your highly sensitive work applications right through the encrypted, slightly slower VPN tunnel while simultaneously letting your other apps like Spotify or Netflix access the internet directly at full speed. It's an incredibly practical way to conserve bandwidth while keeping your confidential files secure exactly where it matters.
Well, that brings us to our final thought for today's explainer. We've seen how the armored tunnel works, the math that locks it, and the protocols that route it. So my question to you is, as digital surveillance intensifies globally and the public internet becomes increasingly hostile, is your data actually prepared to journey securely? It's really up to us to evaluate our digital footprint. I hope this explainer gave you the knowledge you need to make proactive choices about your own network security. Keep learning, stay curious, and I'll catch you in the next explainer.